Welcome to today's Explainer. We're diving headfirst into literally the ultimate manual toolkit in all of optometry, the trial lens set. Today, we're going to walk through the actual hands-on clinical workflow of perfecting a patient's vision from start to finish. So if you've ever sat in that exam chair and wondered exactly how eye care pros piece together your perfect prescription, well, you're absolutely in the right place.
Okay, here's our roadmap for today. We've got 5 sections. First, prepping the trial case. Second, fitting the trial frame. Third, decoding spheres and cylinders. Fourth, the pinhole test. And finally, Section 5, advanced subjective refraction.
All right, Section 1, prepping the trial case. So our journey actually starts before the patient even sits down, right at this beautifully organized, very tactile wooden or plastic box. I mean, a standard trial box is an absolute powerhouse. It holds up to 250 unique lenses, usually sitting right around 237 depending on your exact kit. And because you're going to be constantly swapping these things in and out during an exam, rigorous organization isn't just a nice suggestion, it is absolutely necessary for your workflow. You really can't afford to be hunting around for a specific lens while your patient is just sitting there waiting. To keep this massive inventory ready to go, you have to follow a super strict 2-step protocol. Step 1, thoroughly wipe away every single smudge with a soft, lint-free cloth. Smudges totally ruin the optical clarity. And step 2, always return the lens to its exact numbered slot. So if you pull a -1 spherical lens, it literally has to go precisely back into the -1 slot. Doing this means the next time you reach for it blindly, it's exactly where it's supposed to be. Moving right along, Section 2, fitting the trial frame. Once your lenses are squeaky clean and sorted, it's time to bring the patient into the mix. Now, this isn't just some basic pair of glasses. A high-quality trial frame, like the Oculus model, is an incredible piece of engineering. It has independent screw adjustments for pupillary distance, or PD, which smoothly adjusts anywhere from 48 to 80 millimeters. Plus, you get customizable bridge height and fully adjustable temples. All of this basically guarantees that the optical center of the lenses lines up perfectly with the patient's visual access. What's really brilliant about this design is that the frame features up to 4 distinct compartments on each eye. It's a setup that lets you seamlessly stack lenses. You could drop a high-powered lens in the first slot, a standard spherical lens in the second, a cylindrical lens for astigmatism in the third, and you'd still have a 4th slot totally open for accessories, like a prism or a filter. It's a highly customizable optical stack. Now, you might be wondering, in our completely digital modern world, why use this frame instead of one of those massive digital phoropters mounted right to the chair? Well, it's because the trial frame gives the patient a highly realistic feeling. It actually lets them use their natural peripheral vision instead of staring through tiny fixed tubes. It also works great for patients who just can't sit perfectly upright, like little kids or the severely visually impaired. And crucially, it lets you ask the patient to stand up, walk around, and look at the floor. That way you can test if the prescription is actually comfortable in the real world. Okay, Section 3, decoding spheres and cylinders. With the frame comfortably fitted, let's decode the hundreds of lenses you'll be sliding into it. We'll start with the real workhorses, spherical lenses. These generally come in 2 main flavors. In most trial sets, lenses with black rims or black numbers are your plus lenses, and we use those to correct hyperopia. On the flip side, lenses with red rims or red numbers are your minus lenses, which are entirely dedicated to correcting myopia. A really quick, tactile way to test the power of a lens, if you're ever in doubt, is to literally just hold it up against a piece of text. You'll instantly see what it does. A black plus lens noticeably magnifies the image, making it look larger. Conversely, if you place a red minus lens over the text, it visibly minifies it, shrinking the image right down. It's just a fantastic, practical way to confirm exactly what you're working with. Building on that, we also have cylindrical lenses. These are specifically designed for treating astigmatism. You can spot these in the box super easily because they have 2 sharp axis lines printed right on the edge. And here's a fun little trick. If you look through a cylindrical lens at a straight line and slowly rotate it, you will actually see the image tilt and distort. That right there is the astigmatic correction happening in real time. Section 4, the pinhole test. So when a patient sits down and their visual acuity just isn't hitting that crisp 20/20, our very first troubleshooting tool is the pinhole accessory. This thing acts as an essential diagnostic crossroads. It is exactly what it sounds like, an occluder with a tiny little hole right in the center. What it does is narrow the beam of light entering the eye, totally eliminating scattered peripheral rays. And by doing that, it helps us pinpoint exactly why the patient's vision is decreased in the first place. Here's the absolutely crucial part. If looking through that pinhole suddenly improves their vision on the eye chart, you are dealing with a refractive error. That's great news because it means you can fix the problem using the spheres and cylinders sitting in your trial box. But if the pinhole doesn't improve their vision at all, then you've got to suspect an underlying eye pathology. That tells you the issue isn't just about how light bends, but maybe something is going on with the retina or other structures of the eye.
All right, Section 5, Advanced Subjective Refraction.
Assuming the pinhole test did indicate a refractive error, we move into the final, most intricate phase. This is really where the art meets the science, because the patient's active feedback is going to directly dictate the final prescription. When you're fine-tuning the power, there's a strict clinical protocol to follow. You always push plus lenses if the patient says their vision is clearer, or even if they notice no difference at all. You basically want them to have as much plus power as they can comfortably tolerate. But you only ever increase a minus lens if they explicitly tell you their vision has genuinely improved. This is so important because it prevents the trap of over-minusing the patient, which can cause them some pretty severe eye strain later on. Now, to stop the patient's eye from instinctively over-focusing during the exam, a little reflex we call accommodation, we use a really clever technique called fogging. We intentionally add a plus lens, usually about plus 1.0 diopter, to artificially blur their vision back about 2 lines on the reading chart. Then we just gradually reduce that plus power, step by step, until they hit a crisp 20/20. This guarantees we're getting their true resting prescription. Finally, to verify that our dialed-in prescription is absolutely flawless, we use the duochrome test. This is an incredible binocular vision test where we place red and green filters over the patient's eyes while they look at black text on a screen. We just ask them a very simple question. Do the black letters look sharper on the red background or the green background? If they say the letters are sharper on the red, the patient is slightly undercorrected for their myopia and needs a little bit more minus power. But if the text pops and is sharper on the green background, it means they are hyperopic in that moment and need slightly more plus power. Based on what they tell us, we carefully tweak those lenses by tiny quarter diopter steps, and we stop adjusting exactly when the patient confirms that the black letters look equally dark, crisp, and sharp on both the red and the green backgrounds. That perfect equilibrium, it signals that our optical correction is perfectly balanced right on the retina. As we wrap up today's explainer, I want to leave you with this final thought. In an era completely dominated by modern digital advancements, high-tech lasers, and automatic push-button for opters, why do you think eye care professionals still universally trust this manual, tactile wooden box of glass lenses? Well, perhaps it's because vision isn't just a mathematical equation. It's a deeply human, highly subjective experience. And honestly, nothing gives a patient a more realistic preview of their newly corrected world than getting up and walking around with a trial frame. Thanks so much for joining me to decode the trial and set today, and keep your eyes open for more explainers coming your way soon.